which one?
Is that another? Like it's 74.
What kind of chips are those? It smells very strong.
Okay. Carmen,
Chips or
Carmen, pass me some chips.
what flavor is it? Oh, it's just sea salt. No, it's probably your food. Oh, does that smell like sea salt chips?
No. What do you have?
Alright, so slow down and review your algebra. I made a mistake on this that we're going to go through. I had this factor here. When I recopied it as x plus 2, which made every sign for the very end of my things all go wrong, and I had to go back and fix it. It's so easy to make a mistake, and it's not even much, but this is what the book wants you to do. They want you to then, once you're done with this, use your calculator to verify your function. Please don't skip this step. So everybody pull out your graphing calculator. Let's assume this was on the quiz, and I said you had to do this algebraically, and you were like, I feel about 20% confident that I'm right on this. Graph it on your graphing calculator, and you should be able to verify generally that it's right. You should be able to see this 0 and no other zeros. It won't be perfect, but at least if it crosses somewhere other than 2, you screwed up. And if it has other real zeros that you don't have, you screwed up. So everybody go ahead and try graphing that on your graphing calculator. In the book, the instructions will actually ask you to do this. And see what you get. Good job. You lost your X on it, so you might.
Use your graphing calculator.
Still thinking. Corner.
It's so weird. It has that yellow like loading.
Yes. You're asking your calculator to do a lot, so it might take a while.
What are we supposed to be?
So when you're done with it and you get this, the book asks you to graph this on your graphing calculator to verify it. Basically, you should see this 0 and no other zeros. So at least if it doesn't show that up, you'll know it's not right. So, who's gotten the graph of this? You gotta play with your window. Okay. And it does cross at 2 and nowhere else. So, like Carmen graphed it, it's not beautiful, but at least you can look at it. The lack of beauty is not your fault. It's the calculator. It's very pixelated. But her calculator does confirm that it crosses at positive 2 and that is the only real 0. So, it gives you a measure of security that maybe you did this right. Okay? So this is the second type of 4. Still thinking? Change your window. You need to zoom in because the 0 is positive 2. Oh yeah, your window is massive. From negative 1,000 to a positive 1,000. Try negative 10 to positive 10.
Wait, next week, Saturday?
Alright, so that's the first 2 types. First type, super easy, just name the zeros. Second type, same thing, name the zeros and then smush them all together to make an equation. Alright, third type that I'm going to give you guys.
Wait, what's the second type?
This is the second type.
Oh.
Where you name the zeros and multiply to get the equation.
What's the first type?
First type was just naming which other zeros there are. Super easy, like no work. Okay, third type is use given zeros to find the rest of the zeros. Alright, so here we go. This is type 3.
What was the first type?
First type was just name all the zeros, don't do anything. Alright, so third type of problem is this. The instructions say use the given 0 to find the remaining zeros. So let's do this one. So here's the function, f of x equals 2x to the 4th plus 5x cubed plus 5x squared minus 12. So they're going to give you a function. They're going to give you a 0, 1, 0, and they're going to ask you to find the rest. So then they're going to tell you that the 0 is negative 2i. And that's all they're going to tell you, and then they're going to say, find the rest of them. All right, so we found another one. We definitely know one more. How many should you have, though? 4. We only know 2. Okay, so we know that another 0 is also going to be positive 2i, but I'm still missing 2. So how am I going to find the last 2 zeros? The graphing calculator could guide you, but I will need to see the mathematical solution. Okay, Carmen says I could factor to find the real zeros. Would I want to try to use the negative 2i and the positive 2i first to create, remember it's called a depressed equation? When you pull out some factors and you get what's left from those factors out, we call it a depressed equation. Do we want to try that first? Or do we just want to go with the factors right away? You could just do, you know, the idea of the plus or minus this and the plus or minus factors of this, and you list all the possible factors and you work it out, right? Everybody remember that. That's what we're going to have to do eventually, is it's all the factors of this divided by all the factors of this gives you all your possible zeros. Don't start there, though, because we know 2 zeros already. Make it simpler. So you know 2 zeros. So what do those 2 zeros combine to? If these are my zeros, it would be an x minus 2i and an x plus 2i. Yep. What is that if I multiply it out? This is part of my function. This is x squared plus 4. Yes, minus 4i squared, but the I squared is a negative 1, so it's plus 4. All right, time for some polynomial long division.
Oh no. Really?
Vivian has the best nose scratch ever. Ew. You can divide this out, because you already know this is 2 of the factors here. So, I could do this. I could do x squared plus 4 divided out of 2x to the 4th plus 5x cubed plus 5x squared plus 20x minus 12. And then what I get left, I could... You guys remember how to do polynomial long division? No.
Because it's negative.
So, you look at the first term into the first term. What do you need up here so that this times this makes that? 2x squared. Okay? Then you take this and you multiply it by each of these and you put it underneath to subtract, right? So, 2x squared times x squared is 2x to the 4th. 2x squared times 4 is plus 8x squared. You have to write it underneath the same term here, though. Do you guys see this? Notice how I shifted that over. Why did I shift it over? Because it's a squared, it's not a cube. There is no cubed function here, so we kind of, or the single function here, we treat it as like a 0. Okay, then what do I do? Subtract, right? So this minus this is nothing, so this would be 5x cubed. Careful, you're subtracting though. Minus 3x squared. And then we do the same thing again. Lead coefficient into lead. So what do you have to multiply by to go from an x squared to a 5x cubed? 5x. Okay? 5x. Multiply. This times this. 5x cubed. Okay, I'm going to bring down my 20x here. 5x times 4 plus 20x. Okay? Again, lining them up so that I can subtract them. Then what do I have left? Nothing. Negative 3x squared. These subtract off, right? So nothing. And then I can bring my last term down to minus 12. The 20 came from 5x times 4 makes 20x. When you divide, you're just looking at the first leading term to leading term, but when you multiply to subtract, this gets multiplied by both terms. Because the 20 was a 20x, x to the first power, I didn't have an x to the second power. You could have written this over here if you wanted. You could have written it as x squared plus 0x plus 4. It's kind of like just a placeholder. There's no x to it. It's just that way. Yeah. So you could think about it like that. All right, lead into lead. It would be a -3 needed, right? -3. Multiply it out. -3x squared minus 12. All right, take a look. If this doesn't make 0, you screwed up if this doesn't make a remainder of 0. Why? Why do you know you screwed up if you don't get a remainder of 0 on this division? Yeah, because the thing is supposed to be a 0. If it's a 0, there's no remainder. If you get a remainder, you screwed up. So this has no remainder. So take a look. All we have to do now is factor this, and we'll be done. So let me show you what we're doing. We're taking this function, and now I could rewrite this function as the product of the x squared plus 4, which is what I got from the 0 they gave me and the conjugate theorem, multiplied by what I got when I divided it. And then this can be factored. So we know that this is the x minus 2i, x plus 2i. That's what we had. And then this we can factor. What is it? 3, 2x minus 1 plus 3. Plus 6 minus 1 makes plus 5 makes minus 3. I have all 4 zeros.
Yeah.
That's it for this style.
Yes.
If you are feeling really sketchy on this, there is review. There's a page in the appendix that reviews this for you. Yeah.
If Tom asks you to find the remaining zeros, can we get in that factory form with that?
It says find the remaining zeros.
Actually, we have to, like,
What the book does is it just lists all the zeros in the end. So it says find the remaining zeros. So then basically your answer and your answer line would be 2i plus or minus 2i, 1/2, -3.
okay.
So you basically just list the zeros. Okay? Did I have to do polynomial long division?
No.
Could I have done a synthetic? Could I? Could I have done synthetic division? Okay, talk it through. My question, everybody hear this. This is good to understand when is it useful, when not. Could I have done synthetic division here and not polynomial long division? Because generally synthetic division is what we use to knock out a 0 after 0 after 0. Yeah, this has 2 zeros in it as well, right? Okay, so everybody hear this for a sec. Ready? Everybody hear this. I took 2 zeros and combined them together here first. So then the fastest thing to do is just to do a polynomial long division and remove them. You can do synthetic division to remove zeros, but you remove them one at a time. Do you want to do synthetic division by 2i? Or -2i? No. We don't want to do synthetic division with complex numbers. But if you know you have the plus or minus, when you multiply them together, you get this. You can divide this. So this is where you'd want to do long division. Okay? This is what I'm going to do. We've got 14 minutes left. I have one more style of problem to show you. I'm going to show you that, and then if there's enough time, I'm going to come back and have you do another example of this with me and the other one. And my goal was to do 2 examples of each type. But I want to make sure I get this 4th example in. Okay? So if we have time, I'm going to give you another example. But let's jump to the 4th style first. Okay, so type number 4 for your homework. This is the rocket launcher to the face type.
Yeah.
Or maybe I'm just skipping you. Okay. The last type is basically just find the complex zeros. They're just going to give you a function and they're just going to say find them. So they're just going to say find the complex zeros, and they're going to give you a function like this: f of x equals. What I want to do is 33. F of x equals x cubed minus 8x squared. Plus 25x minus 26. No other instruction, just find them. Nope, they're not here. Move on. What do you do? How do you find zeros? If I just say find the zeros, what's your method? Okay, graphing calculator guides you. But how do you know the possibilities? The what? Degree. So you know that you should have 3 zeros for your answer. What do you know because it's a third degree?
There's only one real zero.
There's one real, which means the other one is going to be a plus or minus conjugate. Okay, that's kind of nice too. How do you know the real zero? How do you know the list of possibilities for the real zero?
PQ.
The PQ thing. You guys remember the PQ thing? Okay, so let's do that first. So, PQ thing, what is it? What are my options? But the graphing calculator will limit it, and we're only going to try the one we know from the graphing calculator. So what's the PQ thing? 1 and negative 26. Which one goes on top? 26. So we're looking at plus or minus 26, plus or minus 13, plus or minus 2, plus or minus 1. I'm taking the factors of this divided by the factors of this. All right, graphing calculator now, go. You don't blindly just guess and check this. You look at your graphing calculator, you find the zero, and then we use synthetic division to factor it out. So I'm guessing it's plus or minus 2 or plus or minus 1. Maybe it'll surprise us and be a 13, but everybody graph it and see. 2. 2? Positive 2? Okay. So your graphing calculator tells you it's 2. So now do synthetic division and take the 2 out. Do you put a positive 2 out front or a negative 2 out front with synthetic division? It's always the little things that mess us up. Do you put a positive 2 out front or a negative 2 out front? Positive. Okay. You gotta keep reaffirming that. The factor is x minus 2. The 0 itself is 2. The 0 goes up front. So we're gonna put a 2 out front, and we're gonna do 1, negative 8, 25, negative 26. We're gonna get the depressed equation from this, which then we can factor to find these complex roots. If you don't get 0 here, what happened? You messed up, right? Because we know it's a 0. Okay, so then this right here is what we create. The book calls this the depressed equation. It'll all be alright. So that's this. Is this going to have real or complex roots? You should know the answer to that from what you saw in your graphing calculator. Complex? Okay. So how do I find complex roots of a quadratic? What do I do? Can I factor it?
You cannot.
No. How do you find complex roots?
Quadratic.
Quadratic formula! Yay! Okay, so if you're looking for complex roots, it's not factorable. It means now use the quadratic formula. Negative b, which is 6, plus or minus the square root of b squared, which is 36, minus 4ac, which is 52, over 2a, which is 2. So this would be 6 plus or minus the square root of negative 16 over 2. Square root of negative 16 is 4i. So this would give you 6 plus or minus 4i over 2, which you can reduce. Divide the 2 out, which is going to be 3 plus or minus 2i. You have now found all of the zeros of that function. 1, 2, 3 zeros.
But it says find complex zeros, so the answer is actually just.
It says find the complex zeros, but I mean, if you want to be technical, 2 is a complex number. It's just 2 plus or minus 0i. So we'll still list it. So the zeros are 2, 3 plus 2i, and 3 minus 2i. Those are your zeros. And that's your final answer. Okay, we've got 7 minutes left. Tell me, was that third type or this fourth type more complicated, and which one would you rather practice? Third type with the potential of having to do the long division? Okay, so I'm going to give you one more example of that third type right now. Okay, so let's do f of x equals x to the 4 minus 9x cubed plus 21x squared plus 21x minus 130. And then the 0 that I'm going to give you is 3 minus 2i. And I want you to find the rest of the zeros. This is like number 3. The instructions are basically use the given 0 to find the rest of the zeros. So the instructions are use the given 0 to find the remaining zeros. Okay, what did I do first? The other one's 3 plus 2i, using complex conjugates. Multiply those together to figure out what's one of the depressed equations of this. And then you gotta divide it out. Go. Pencil on paper, practice. Try it on your own. If you're confused, you can look up at the board, see what I'm doing, but try not to. See if you're able to follow this through, and then just verify yourself when needed.
Oh.
Yeah, it just ended up being the same factor. I know, that seems weird that it's popping out that same thing as we got before. This book, for some reason, likes to use 3's and 2's for their, like, this is 3 minus 2i. They use it a lot. It's really weird. Whoever wrote this book just tends to use the same complex numbers all the time. You're not going crazy. So you guys should be multiplying the two factors you know together to find the depressed equation that will go out of it, and then you should be doing long division to find out what's remaining. The long division is what might get you. Remember, you start with the lead coefficient only. If there's ever a term missing, you should put a 0 there, or like a space to hold it. In this case, we don't have to. Don't get a 0 in your long division, you have a mistake, which I must have a mistake.
Mrs. Griffin,
Yes.
what is SAT cube?
This is 10.
I go.
Is that my only mistake? Yes. So then this is 10.
SAT cubes.
So I ran into a problem here. My thing wasn't equaling 0. If you run into that, it's kind of nice because it lets you know you messed something up. And then you got to go back and fix it. In case you guys are wondering, 21 minus 13 is not 7. That's 8. Okay, so the whole goal of this was to get this, which then I can factor to find the rest of the zeros. Is that factorable? So this becomes minus 5 plus 2? Okay, so then my zeros are 5, negative 2, 3 minus 2i, 3 plus 2i. So 5, negative 2, and 3 plus or minus 2i. Those are my zeros. Alright, so your homework, 4 types. Vince, move, thank you. Not move isn't just like do this, which is what I'd be telling you. Okay, so I will post your homework on the homework page. Looks like type 3 is going to be the most laborious. We get 5. Yay! I'm managing some sports.
You don't have minimum SAT issues and also if you have higher issues and SAT.
It's really like
Somebody get 900. I think.
low expectation. 15.
Someone are cool about 3. You know it's 3 really? That is so bad. I'm gonna call report.